Hello and welcome to my talk on running Loggregator in production with minimal log loss. Today I will talk about how we run Loggregator at ACP, and I hope I will help you improve the way you are running it in your own foundations as well. My name is Jovan. I work at ACP as a senior software engineer in the ACP BTP Cloud Foundry core department. In my free time, I'm contributing to free and open source software projects and chill with barbecue and beer. You can reach me anytime on Twitter. Today, I want to give you a short overview of Loggregator, talk about the challenges which you may face running it, and give you some insights on running and monitoring Loggregator. Loggregator is the Cloud Foundry's logging stack. It is Cloud Foundry operators' eyes and ears to what's happening in the system. It is responsible for highly available and secure streaming of logs, metrics, and events from the log producers to their consumers, which usually are some kind of monitoring and logging systems. It does all of that without affecting the application's behavior. It also provides unified format, log envelopes for the logs, metrics, and events. The Loggregator is positioned between the log producers and consumers. It will give its best to ingest and deliver the log envelopes as fast as possible, but if the log load is too high for the current scaling, it will drop the envelopes it cannot process. Depending at which point the drops happen, there are ingress and egress drops. The whole mastery, as suggested by the Loggregator's documentation, is to keep the log loss under 1%. This can be done by controlling the amount of log envelopes which get ingested and scaling Loggregator properly for the load that it should handle. The most common way of deploying Loggregator is the Firehose architecture, where all of the log envelopes from the applications and platform components are aggregated in a single log stream called the Firehose and forwarded to the customers. There is also a cache, which is used by the cloud controller to read the application events and when executing the cflogs command. There is another way of deploying Loggregator called the shared nothing architecture, but unfortunately, it does not have big adoption in the industry. On the Bosch VMs, there are components which collect logs, metrics, and events using different protocols, aggregate them, and send them to the Dopplers or some third-party logging server. When using the Firehose architecture, everything is aggregated together, and it can happen that if some applications log too much, they might cause log drops. Dropping metrics from platform component means problems with our monitoring and alerting. If something went wrong, we will be informed later or we will be not informed at all. As the cloud controller reads data from the log cache, there might also be degradation of the Cloud Foundry API. On the other side, some of our users will have log loss because there are other applications logging too much. This is why we should always think or even predict some log load fluctuations and scale the system properly. No one wants outages. No matter how fancy our foundation is, it is our users' playground and they will do all sorts of weird things with it. That's why we should set some guidelines and rules. How are we running and configuring our foundation, document them, and communicate them with our users. Write all of the limitations and specifics of our foundation setup. Many people come with different expectations based on the systems that they have previously worked with. On top of that, Cloud Foundry is open source software, availability of the code and the documentation makes our users think that we support everything with strict guarantees. It is always better to have few unhappy users than having most of our users be mad at us. The noisy applications in context of Loggregator are applications which produce too many logs and with that are affecting the delivery of the log envelopes in the system and can cause envelope drops. The usual problems with the noisy neighbor applications are setting inappropriate log level for production. Applications are unable to connect to a particular services which they're using, retry all the time and produce stack traces. The applications can also be built in a way that they produce too much logs, or they can even be deployed broken. From time to time, there might also be applications doing some performance tests, and because of the high number of HTTP requests, the number of the Gorouter access logs rises. We have a customer, they were really happy with their solution, microservice architecture, they get lots of traffic to their applications, everything works perfect for them. But for us, they were producing 2 to 3 logs extra for each log line because of wrong use of the syslog drains and sending the logs around with HTTP requests. Analyzing the problem with the high number of HTTP requests, we have seen that the messages from the control plane align with the request rate from this customer solution. This led us to the Gorouter, where we saw that there are some metrics sent for each request. We've contributed to the Gorouter to make the sending of these metrics configurable, and we've drastically lowered down our overall load. You can hear more about this in the talk of my colleague Stefan Lai. Now that we understand why the reliable logs and metrics delivery is important, let's discuss about how do we handle these problems. We should continuously monitor the log production and the system behavior so that we can adjust our setup accordingly. As CF operators, usually we're not allowed to affect the running of the customer applications. Therefore, I highly recommend you that you have a direct contact to your customers so that you can discuss the problems which they cause and take some actions. If you cannot achieve this, find someone from the accounting team who can contact the customers. In some extreme cases when something went really wrong and you're on a bridge call and you don't have time to contact the application owners, it is really helpful if there is someone on the call that has an authority to permit stopping of the problematic application. Above all, we should talk to our customers to help them understand how Cloud Foundry works and architect and develop their solutions so that we're not awakened at 3 a.m. in the morning because of an outage. So how do we monitor the log noise? The quickest answer to that question is that we use the noisy neighbor nozzle. That's true, but we should think about scaling it properly so that we don't cause log drops. The better way to monitor the log noise is to use the log cache API directly programmatically or via the plugin. The huge advantage of this approach is that we don't connect to the Firehose directly and we cannot cause any drops. The log cache API has REST and Prometheus endpoints, and we can do all sorts of monitoring actions and automate everything that we want. At the beginning, it will be a bit challenging to find data in a particular time frame, as there is a lot of it, and the start and stop timestamps are in nanoseconds. Here's an example how easy it is to gather the noisy applications, the organizations and spaces that they're running in and find who to contact in case of problems. So far, we've seen how the noisy applications can harm the log delivery. Apart from the total log throughput being limited by the scaling of the loggregator's component, there are some limitations implied by the way some of the loggregator components are built. We had a problem a few years ago that some noisy applications would practically do a denial of service attack by sending too many logs, and the cloud controller would not get the events from the application in time, which resulted in crashes when executing CF push. Nowadays, the CF push problem has been fixed, but we could still miss events in the cloud controller's database due to the log drops, which means degradation of the CF API. After initializing a discussion with the colleagues from the logging and metrics and Diego teams, a new configuration parameter was introduced in the Diego, which limits the number of logs from an application instance which will be forwarded to Loggregator. The application log rate limit is applied per application instance and can be configured with the max log length per second parameter. The application log rate limit implements the token bucket algorithm. You might experience that some applications spin up more instances to get around this limitation, but they would be probably limited by the given application resources. If that's not the case, then this would be your bigger customers, so you will know about them anyhow. The suggested value for the application log rate limit is a minimum of 100 log envelopes per second per application instance, but we should think about the fact that not all of the applications log equally and not all of the time. Setting the limit too low will cut off some possibly valuable logs for our customers, which is not good. The best way to set a proper value for the log rate limit is to analyze the number of logs which the noisy applications produce and decide where to make the cut. There is also a Diego rep metric which shows how many application instances have been rate limited. As I've already mentioned, all of the loggregator components ingest and forward log envelopes, and if they fail to do so, there will be drops. Loggregator by design has metrics for these parameters. Most of the components share a common ring buffer called a diode, which is used to write and read the log envelopes. The buffer emits metrics for received, sent, and dropped logged envelopes. Monitoring these three metrics plus the CPU and memory utilization of the VMs covers most of our use cases. If you need some data from the loggregator, there is a really nice client library. To scale the loggregator components properly, we can take a look at their documentation and their source code. Most of the components have documented all of their scaling recommendations. Apart from the documentation, we should take a look at the ring buffer size and how are the components co-located on the VMs. The forwarder agent runs on every Bosch VM. There is no scaling possible. The size of the ring buffer is 10,000 logs envelopes, and if you go above it, there will be drops. At the moment, the ingress drop metric is always 0, so check the logs. Another problem which can occur in case of big log messages is that gRPC can drop messages because the delivery of the logs from the Diego to Loggregator is done in fixed size batches, and the total size of the batches is bigger than the allowed maximum message size for gRPC. For the Loggregator agent, the situation is similar as for the forwarder agent. The syslog agent sends the logs to external third-party logging servers. The scaling is the same as for the other Loggregator components running on the VMs. Slow consumption of the data from the third-party logging servers will result in drops. The Dopplers have clear scaling guidelines. They should be scaled based on the overall log envelope volume. They should be scaled up if their ingress drops or their CPU usage is too high. The log cache has a ring buffer of 10,000 log envelopes, so the load should be kept under this value. It has some configurable capacity limitations, but they don't affect the drops. When the limits are reached, the log cache prunes old envelopes to make room for new ones. It is important to mention that it is deployed on the Doppler VMs, and we should be careful when scaling the Dopplers so that we don't cause log drops, because they mean missing application events and degradation of the CF API. Another thing worth mentioning is that all of the log cache nodes are connected between each other via ring buffers, and the ingress and the drop metrics are emitted separately per each connection. As the log cache is deployed together with the Dopplers, if we care about it not to drop, the Doppler should be scaled to accommodate 10,000 log envelopes per second. The reverse log proxies have clear scaling indicators. From our experience, we have noticed that it is enough if the number of log API nodes is 1/4 from the number of the Doppler nodes. In case we have many Firehose nozzles, we need more of them. There can be also uneven distribution between the Dopplers and the RLPs, as the Dopplers can finish starting before all of the RLPs, and some of the RLPs don't get any load. It can also happen that over time the CPU of one of the log API nodes rises gradually and it starts dropping at around 90% of the CPU usage. The Firehose nozzles should be always scaled accordingly to the load they consume. If they're too slow, there will be egress drops in the RLPs. We should be careful if we use external nozzles, as if they drop, it cannot be identified which nozzle causes the drops. At SAP, we have many foundations where the Loggregator load ranges from 2.5 to 270,000 log envelopes per second. We have two Firehose nozzles attached to the Firehose. One of them is for the application logs, and it processes the logs and stores them in ELK. For the metrics, we have another nozzle which forwards the metrics to Riemann, which is a stream processor where we create some aggregate metrics and fire alerts. The metrics are stored in InfluxDB, and we're using Grafana for visualization. Now let's take a look at some dashboards which we have for monitoring Loggregator. This dashboard shows the overall envelopes egress from all of the VMs, and overall egress from the Diego cells, as well as overall Doppler ingress. This way, if there are log fluctuations, we can immediately see where does the log load come from and if the Dopplers can ingest it. For the Dopplers, as well as for the other components, we monitor the CPU and memory usage and ingress, egress, and drop rates. For log cache, apart from the usual metrics, we are monitoring the capacity of the cache and its memory usage. For the RLPs, we have the usual metrics plus the metrics for the traffic controller, which are usually 0 as we don't use Loggregator's version 1 API. For the syslog agents, we have the usual metrics for all VMs and Diego cells separately, plus the number of the registered and active drains. We have done one load test of Loggregator in 2019, where we have concluded the shown load and scaling limits. This year, we have done another one where we've concluded big improvements. So thanks to the logging and metrics team and the whole Cloud Foundry community for making this happen. This is all with the upstream CF deployment release. We have concluded that the Loggregator might even do better if the Dopplers and the log caches are deployed separately. Log cache, the component with which we've experienced most of the scaling problems, is unfortunately the worst documented one. In the future, we will continue our active participation in the community and help making Loggregator even better. I want to thank my teammates from the Cloud Foundry Core 42 team at SAP for having the courage to join me exploring the world of Loggregator, Colin and Kai for helping with organizing and doing the last load tests, and the logging and metrics team at VMware, especially Ben, for helping us to get better understanding how the Loggregator works and how to solve our problems. Because of the virus, I still owe him few beers. At the end, I want to thank you for your attention, and I hope to see you in the Q&A session. Bye.